Hello, this is the second video for section 8.8. To add and subtract complex numbers, you add or subtract the real parts and imaginary parts separately. Example 5, perform the following operations and write your answers in standard form. So again, you just combine the real parts, so that becomes 3 minus 2 plus -1 plus 4i. So that's 1 plus 3i. The real part, now in part B, we have 3i plus 5 minus 3i. Well, the 3i and -3i will cancel out, and our answer is just 5. Part C, 4 minus -1 plus 5i plus 7 plus 2i. First thing you have to do is distribute this negative sign. So this becomes 4 plus 1 minus 5i plus 7 plus 2i. 4 plus 1 plus 7 is 12. -5i plus 2i is -3i. Part D, square root of -27 plus the square root of -48. Well, that's I square root of 27 plus I square root of 48. Instead of doing factor trees, I'm just going to use the largest perfect square in each number. So that's 9 times 3 for 27 and 16 times 3 for 48. So this becomes 3i square root of 3 plus 4i square root of 3, which when you combine like terms is 7i square root of 3. All usual multiplication rules hold for complex numbers. Just remember, I is the square root of -1. I squared is -1. I cubed would then be negative I, and I to the fourth would equal +1. So when you have powers of I, you can simplify them. Example 6. Perform the following operations and write your answers in standard form. 7i times -3i is -21i squared. From up here, I squared is -1, so that's -21 times which is +21. Part B, we still have to distribute. So we get 8 plus 6i minus 4i minus 3i squared, which is 8 plus 2i minus 3 times -1, which is 8 plus 2i plus 3, which is 11 plus 2i. Here, don't forget when you square a binomial, you just write it out twice. Do not distribute the exponent. So we get 9 plus 6i plus 6i plus 2i squared, which is 9 plus 12i plus 2 times -1, which is 9 plus 12i minus 2, which is 7 plus 12. And part D. Remember, we cannot multiply the square roots together. You have to take the square roots first. So we get 6i times 2i, which is 12i squared, which is 12 times -1, which is -12. Dividing complex numbers is much like rationalizing a denominator. We multiply the numerator and denominator by the denominator's complex conjugate. The complex conjugate of a plus bi is a minus bi. So in other words, the complex conjugate of bi is negative bi. So you're always making the imaginary part the opposite sign. So a, because the denominator is a 4i, I'm going to multiply by -4i. You distribute on the top, we get -8i plus 4i squared all over negative 4i squared, which is negative 8i plus 4 times negative 1 all over negative 4 times negative 1, which is negative 8i minus 4 over 4, and that can be reduced to negative 2i minus 2. Part B, 5 over 3 minus 2i. The complex conjugate of 3 minus 2i is 3 plus 2i. This becomes 15 plus 10i over 9 plus 6i minus 6i minus 4i squared, which is 15 plus 10i over 9 minus 4 times negative 1, which is 15 plus 10i over 9 plus 4, so 15 plus 10i over 13. Part C. The complex conjugate is 8 minus I. So we'll multiply the top by 8 minus I and the bottom by 8 minus I. So we get 64 minus 8i minus 8i plus I squared. 64 minus 8i plus 8i minus I squared, which then becomes 64 minus 16i minus 1 all over 64 minus negative 1, which is plus 1, and then that simplifies to 63 minus 16i all over 65. In the last example, the complex conjugate is 4 plus 2i, so I'm going to multiply by 4 plus 2i on top and 4 plus 2i on the bottom. So that becomes 8 plus 4i minus 12i plus 6i squared all over 16 plus 8i minus 8i minus 4i squared, which is 8 minus 8i plus 6 times negative 1 over 16 minus 4 times negative 1, which is 8 minus 8i minus 6, 16 plus 4, which then becomes 2 minus 8i all over 20, which can be reduced by 2, so we get 1 minus 4i all over 10. And that is the end of section 8.8.